All right, so we are going to start with number 22 from the homework, since we just went over the answers to the homework. And Angela, read it off. It says y varies directly. Is that, or how does it say it? Inversely. Okay, so y varies inversely as. Okay, hold on. So y varies inversely as the cube of x. So inversely, where's the cube of x means x cubed, right? So where does that go if it's inverse? On the bottom, right? Okay, keep going. Inversely is the cube of x. And directly as a square of z. Okay, good. So directly, we put that on the top, and you need a k on the top, all right? So you need a constant. You could put it out front. It's the same thing as putting it on the top. Could you put it on the bottom, the k? No. All right, you got to have it either out front or on the top. All right, so that's what we start off with, all right? And now they tell you if what? Y is equal to -6, x is equal to 3, and z is equal to 9. So that's the information they give us. What we want to find is what is y Okay, here it is. Just lost my spot. Okay, find y. So here's what they ask. They say find y when x equals 6 and z equals -4. Is that right? Okay, good. All right, so all these problems are pretty much the same, all right? It's just substitution at first, right? Just plug in a bunch of stuff. You solve for k. Once you solve for k, make a new equation, and then put these things in, and then get y by itself, because I will have my k after I find the k right here. So the key to this is to find the constant, all right? Because they give you everything else you need to know, all right? So let's find the constant. So y is -6 equals k. We don't know what it is, so we're trying to find it first. And then z squared, so z is 9. We square that. And then x, which is 3, and we cube that. So again, what are we trying to do? We're using all that information to solve for the constant, solve for k. All right, so let's do that. -6 equals k. 9 squared is 81. And then 3 cubed is 27. That goes even, doesn't it? Three times? Yep. So that goes 3 times. Agreed? Yeah, you can put it in a calculator. It's fine. And then let's just do this. Instead of writing everything down again, I got k times 3, or 3k. So what do I do with that? 3. Divide both sides by 3. So I just kind of combined a bunch of steps into one, and k is -2. Is that my answer? Am I done? No, because they give me other information, and I got to find what is the y going to be if the k is -2, and the x is 6, and the z is -4. So let's rewrite this equation. Y equals, now we know what the k is, it's -2, right? Times z squared over x cubed. It's the same as this, but now we found k, and we just replace that k with a -2. And now we do another substitution. Just put those other things in here. Oh, they make this easy because you don't even really have to solve for y, do you? Y is already by itself, so that makes it kind of easy. It's -2 times z, which is -4. That's squared over 6 cubed. What I would do is just put all that into a calculator, and you get -4 over 27. Like I said when I was reading off the answers, if you put it into a calculator and get a decimal, you could just write it as the decimal. I just simplified the top, simplified the bottom, and then had to reduce, all right, and then that's what I got, -4 over 27. But if you wrote that as a decimal, it's fine with me. Make sense? Yeah. They didn't really get any more difficult than that, did they? Yeah, that's probably the hardest one. And they actually kind of made it a little bit easy because they asked for y. All right, so you didn't really have to do any algebra to solve for y. Y was already sitting there by itself. So they made it a little bit easy for you. All right. So now let's talk about the quiz. I will collect that before we leave here today, so remind me to do that. You want it now? Yeah, if you want to collect it now, Connor will collect it. So make sure your name is on it, make sure your lesson number is on there. Because I took a point off on somebody's homework because they forgot their name. So make sure you put your name, because if I got to go hunting to figure out who it is, that deserves a point off, don't you think? Deserves it. All right, so what I'm going to do, let's talk about section 3.8 since we just talked about it. I don't know if there's really much to talk about because it's just the homework problems that we've been doing. So number 7, it varies directly. So I'm going to give you one where it just says varies directly. Yes.
Joint variation. How did we know what to put the exponent on? I forget what number it was, but it said the exponent was a variable, and I didn't know what to plug in for that variable.
The exponent was a variable?
How many questions on this quiz?
Yeah.
How many questions are on every single... no, that's true. That's untrue. Because I have been giving you some with 5. This has 10. All right? Because they're all short and easy. This is not one of those quizzes that's going to take you a really long time. Okay, this should be fairly simple for you. I don't know. You tell me.
I think it was like the third question. I don't know.
I am not... I'm looking through them all.
Can I see the book? I haven't seen my book.
We'll find somebody else. Find somebody's book. I don't see anything where your exponent is a variable.
I swear to you. Can I see your book?
Let's find somebody else's book. Somebody's got a book around. Ask them. Who's got a book? You must be mistaken because I'm looking at my homework that I did, and I am not seeing that at all. All right, let's continue with this. All right, so back to the quiz. So number 7 is it just varies directly, okay? There's no inverse on it. There's no squares on it. It's just real basic. And what do you think the next one is? Yeah, varies indirectly. So if it varies directly, what's it going to look like? Y equals what? Directly? K times X. Okay, and if it varies indirectly, it's what? Y equals, now you can say it, K over X. Good. All right. So number 9. Well, number 9 and 10. We'll put 9 and 10. It's that joint variation. So it varies directly and indirectly. Yeah. And you might have squared in there. Okay, one of them has a square, one of them doesn't. All right, so really, this is joint. Varies jointly. Okay, so varies jointly. Now, one of them doesn't actually use the word varies jointly. It just says varies directly as this and inversely as that. That tells you that it's a joint variation, right? All right, so one of them says jointly, the other one does not, but they're both like that, okay? All right, so that's section 3.8 on the quiz. Super easy. Just went over it. Shouldn't be a problem. Let's go back to 3.7. All right, so here's what I'm going to do. So 1 and 2 are basically the same problem, but they're two different problems. All right, they're taken from the same function. So I give you a function, f of x equals whatever, okay? And then I'm going to ask you two things. What do you think I ask you? find the what? Find the vertical what? Vertical asymptote, and then number 2 would be find the what? Horizontal asymptote. Okay? 3 and 4 is same kind of thing. It's just a little bit more complicated. The first, number 1 and 2 is a relatively simple one, and 3 and 4, same kind of thing. I'm going to ask you for find the horizontal and vertical asymptote. Spent half my day signing passes. All right, so both of these are kind of the same thing. This one's a little simpler. This one's a little bit more complicated. All right, but it's asking for the same exact thing. So how do I know to find the asymptotes? How do I know how to find the vertical asymptote? Where do I look? The vertical asymptote. Look at the denominator. That's right. Okay. So, like if you had a graph like this and like this. Now, they don't give you the graph on 1, 2, 3, and 4, but what if you had a graph like that? What is the vertical asymptote? It would be this one right here, wouldn't it? Now, this could be shifted over, it could be shifted up or down, all right, but that would be the vertical asymptote. How do you find that? You look in the denominator. Remember, let's just make one up. So f of x equals, 2 over x minus 2. All right, so how would you find the vertical asymptote? Right, whatever x can't equal, okay? So what can x not equal? X can't equal, or x minus 2 can't equal 0, so x cannot equal 2, all right? So if you had something like that, that's how you find the vertical asymptote, okay? Does that make sense? What about the horizontal asymptote? Well, we had 3 things to remember. Let's review those 3 things. The first one, you're going to look at the degrees of the numerator and the denominator. Do you remember that? So if you look at the degree of the top degree, and you compared it to the bottom degree, if the top degree is less than the bottom degree, what does that mean? That means if you had like f of x equals, x squared over what? X, give me something else. Let's just say cubed, all right? If the top degree is smaller than that, what's the horizontal asymptote? The horizontal asymptote is y equals 0. All right, so anytime the top degree is smaller than the bottom degree, the horizontal asymptote is always going to be y equals 0. Everybody got that? Okay, here's another situation. What if, I'll just put top and bottom on this one, is that all right, instead of degree? So what if the top is equal to the bottom? So if you were going to graph something like f of x equals, x squared plus x minus 1 over x squared minus 2x plus 3, something like that. You look at the degree. What's the degree of this top one? It's the highest exponent, which would be what? Which would be 2. What's the degree of this one? That would be 2. So what is the horizontal asymptote? Well, actually, let's do this. Let's say this is 4x squared, and that's 2x squared, okay? Let's do it like this. So how do I find what the horizontal asymptote is with this? Do you remember? You should have this in your notes. You divide what? So you divide the coefficients. What do I mean by the coefficients? Well, the coefficients to your highest degree terms. So this is 4, this is 2. So what's the horizontal asymptote to this? It's y equals 2. So what does that mean? That means that on the y-axis, 1, 2, this would be your horizontal asymptote. Everybody with me on that? Okay, so that's what you got to know for that. And then there's the third one. So you got the top is less than the bottom. You got the top is equal to the bottom. What do you think the third one's going to be?
Greater.
Yes. The top is greater than the bottom. So if you had something like, I'll just make it super easy, x to the 5th over x squared. What if you had something like that? Then what is the horizontal asymptote? Well, let's just do this. Watch. X squared divides into that 3 times, so that's y equals x cubed. What does y equals x cubed look like? It looks like this, and it looks like that. What's the horizontal asymptote for this? There is none, right. Okay, so y equals x cubed, there's no horizontal asymptote. So when the top is bigger than the bottom, now they're not always going to look like an exact x cubed, but it'll look something similar to that. When the top is bigger than the bottom, then there's no horizontal asymptote. I'll just put HA, is that all right? Does that make sense? All right, so make sure you know that for the quiz, because you're going to have to find those asymptotes. All right, so that's 1, 2, 3, and 4. Then we got 5 and 6, and that'll be it. So 5 and 6, what'd you have on the homework? They give you a what? They give a graph, right? So they're going to have a graph on there, and same thing on the quiz. Okay, there will be a graph on the quiz, and what you have to do is write the equation of that graph, all right? So when I say, I'll say given a graph, okay? You're given a graph, and you have to write the equation of that graph. So write the equation of it. Now, here's what they're basically going to look like. These are inverse graphs, okay? So what's a basic inverse graph look like? F of x equals 1 over x. What does that look like? Well, you got a vertical asymptote, right? Let's go back and look at this. The degree of the top is less than the degree of the bottom. Do you agree with that? The degree of the bottom is 1. The degree of the top is 0, right? Because there's no x up there. So what kind of horizontal asymptote are we going to have? We're going to have, yeah, right there, we're going to have it y equals 0. So I'll just show you the graph first, and then we'll talk about that. I should have done that first. So this is what that function is going to look like, with no other numbers associated with it. Okay, we didn't shift it left or right, up or down, or we didn't make it skinnier or fatter or anything like that. Okay, that's just your basic everyday parent function of the inverse graph. Everybody good with that? Remember that? Anybody responding to me?
Yes.
Do you remember this? Okay. All right. And if you don't, just say, nope, don't remember it. Well, we did it. All right. So go back and watch the video on it. What was I going to say with this? So what's the vertical asymptote? How do I find the vertical asymptote?
Oh, it can't be 0?
Can't be 0, right? Okay, it can't be 0. So that means x equals 0. That's their vertical asymptote right there. Okay, so that's your vertical asymptote. What's your horizontal asymptote? Remember, this is less than this. So the horizontal asymptote has to be y equal to 0. All right, so you know that. So that should help you. What if this thing was shifted, though? Let me see if I can grab it all. Hit shift. that. There we go. All right, so what if this was, oh, I grabbed, here, let's grab this. Let's hit shift and grab that. There we go. I think, did that do it? It still grabbed it. Come on, stop it. Let's try this again. Oh, it's still hitting that white line, isn't it? Daggone it. Oh, I'm so dumb. Let's move this over. Let's start again. All right, let's move this thing over just so I can grab that red one. There we go. All right, so let's grab that. Hit shift, grab this. Group that. There we go. Now we're talking. All right, so that's what it looked like. It makes it so when I grab this, it doesn't grab that vertical line. All right. So watch this. What if I shifted it down and I shifted it to the left? Let's say we went down, I don't know, down 2. What if we went down 2 and we shifted it to the left, I don't know, -3. So we went down 2, which means we went to -2, and then we shifted it left, which means we went to -3. What does that do to this? Shifting it to the left, what does that do to that? Are you answering or you have a question? Okay. What does it do here? What does it do? Yeah, if I shift it to the left, then what's that going to be? The bottom. It's going to be x plus 2. Do you agree?
What? Shows up 3.
Oh, I'm sorry. It's plus 3. I'll blame Angela. She said 2. I just figured she was right and I wrote it down. So right, it'd be x plus 3. Now, you put that over 1. What does the shifting it down do to it? Just puts a -2 out here. Everybody see that? Okay, so if this was your new vertical asymptote and that was your new horizontal asymptote, see it was at 0, 0, right? And you shifted it to the left 3 and down 2. So now that's where that point's going to be, right? And that's how you can figure out what the graph is. So it went to the left 3, which makes it plus 3. You went down 2, so that's a -2 on the outside. Yes?
Do they always move at the same, like, in harmony? Like, or can one be way over here and one's
No, it's still going to be right here,
so
okay?
they're always like the same distance apart?
Yes. So those two red graphs, well, because because that point, like if I go over here and go over here, that's going to be at the same place as here. We just shifted it over to the left. It's just the inverse function. Now, how would that look different? How would that change the shape of it? Well, if you put if you made that a 3, that would change the shape of it, okay? Or if you put something down here and a 2 down here, that would change the shape of it. But we're not getting that complicated, all right?
They're always the same.
For
Is that just
yes,
on
for the
ones,
ones.
or is that in all of them?
Well, we're just making it easy. We're just making it easy because I didn't put a number up here. I put a 1 up here, so it just makes it a lot easier.
So
But if I put a 2, I mean, we could go here. Watch. Let's go to the.
do they ever touch?
Those would not. There are weird situations where you could put a lot of extra stuff in there. Let's see. My internet is going super slow, of course. But let's put a few in just to see. When's this over? I forget. Wednesday.
I don't know.
40? Oh, okay. We got time. If my internet would start working. Here it comes. And I think my computer's about to shut off any second because I didn't plug it in. Hold on. Too many things. Too many things to remember. this in so it doesn't stop on me. There we go. Now we got some power and we got some internet. Good. So let's change this over so I can see Desmos. So let's put that in there. So what did we say it was? Y equals, did you write it down? What was it? Y equals 1 over x minus plus 3, right? So it's 1 over x plus 3, and then minus 2. Is that what I did?
Yes.
There we go. We good with that? All right. Let's put the parent function in there. Just y equals 1 over x. 1 over x. There it is. So that blue one and that red one look exactly the same, except I just moved it over to the left and I moved it down. Everybody with me on that? And so it doesn't matter. If it's just 1 over and then all I did was change that 3 and then change that 2, it would be the same thing. So let's copy and paste that. Let's change a couple things. Let's make that, let's go the other direction. Let's put a minus here. See that green one? So that space in between, it's all going to look exactly the same. Do you see that? That blue one, the red one, the green one, that's all going to stay the same. But what if you, let's do this. Let's get rid of that one and that one. What if you put like a 5 on top of here? See what it did?
Which one is it?
Watch, it's the purple one. So that's what it was with 1. Well, listen, I just changed it back. Okay, that's with 1 over. Okay, but watch what happens when I put the 5. As soon as I put a 5 in here, watch what happens to that purple. Boom. See how it's spread out a little bit? Okay. And what if I put in, let's turn that back into a 1. And let's put like a 5. Put a 5 right there. See what it did? Okay, and then it would even change if I put parentheses around it. All right, so it's a lot steeper here, right? And they're a lot closer together when you put it there. But what does it do? Oops. What happens when I change that, though? What does that do? Let's make a bigger number. Let's put like a 9 in there. Boom. See how it's spread it out?
Yeah.
Okay, so it's not always going to stay. It all depends on if this is not a 1. But what we're doing just very elementary ones right now, okay? We're not doing super hard ones. So we just put a 1 there. The ones on the quiz will be like this, okay? They'll have a 1 over it. You're not going to multiply the bottom by anything. You're not going to have another number on the top or anything like that. These are really just simple elementary ones just so that you can get the idea of what an inverse function is doing, all right? And what it does when you change the denominator and when you add or subtract something to it like that. That's all we're trying to get you to do. So they're going to give you the graph, and you got to figure out what the equation is of the graph. Okay? Does that make sense? Okay.
What are these graphs used for?
Oh, they're used for all kinds of stuff. For sciencey stuff, you could even use them for business stuff when people do business with. There's all kinds of things. Again, we're just learning we're just taking baby steps here. Later on, when you take harder math classes, if you take engineering and things like that, then you'll figure out what these inverse functions do and what square functions do, cube functions, and all that kind of stuff, all right? But right now, we're just trying to get the basics down. We're not learning everything there is to know about math right now. It's just high school. Right? It's just preparing us for bigger and better things. All right, so that's your quiz. I covered everything. So you should be ready for it. I know I didn't do a lot of specifics today, but you can go and look at your homeworks. That's what this quiz is based on, are those 2 homeworks. Now you turn in that 1 homework with the varies directly and indirectly thing today, but I think we got that thing down, don't we? Okay, yes.
So
Oh, I thought you had a question. Any other questions? No? Okay. All right. Quiz tomorrow. Be here tomorrow, please. Because it's a pain if you're not here and you got to take it and then we start teaching something else and all that kind of thing. All right.